Hello, everyone. Thanks for taking your time to check out our Digital Twin Predictive Maintenance Accelerator. If you're currently building or planning to build a predictive maintenance strategy, you already know the primary roadblock is in the AI. It's the fragmented, disconnected silos of data all around. We engineered our digital twin for predictive maintenance at Cavallo Technologies to specifically dismantle those silos. At Cavallo Technologies, we are a 100% Canadian Databricks only company. We have 60 engineers all onshore in Canada with offices in Montreal, Toronto, and also a large presence in Vancouver. Over the last 3+ years, we have been delivering high impact data solutions across data engineering, AI, analytics, and cybersecurity and infrastructure. We at Cavallo Technologies are top 5 Databricks certificate holders with 90+ certifications, and 20+ of those are Databricks professional certificates. So in simple terms, a digital twin in Databricks is like a digital copy of your physical system on the Databricks. So you can observe, predict, and test your systems. This accelerator is a digital twin for predictive maintenance in oil and gas industry, with core focus to deliver near real-time observability of your system-level maintenance risk, asset health, and their respective downstream impact. As mentioned, this digital twin is a replica of your physical system on Databricks. We start by ingesting your raw data into Databricks and then model and process it through the Medallion architecture, all while remaining fully governed by Unity Catalog. So how are we able to achieve this replicable copy of your physical system? Yes, graph modeling it is. When we say a digital copy of your physical system, we also take into consideration the interdependencies, complexity of relationships, and the flows and alternative paths within the physical system and model them as a graph, as a network, as is in the physical system. This creates a true replica of your physical system on Databricks, delivering a near real-time insights. Let's now look at the accelerator in action. We can see the whole accelerator is being bundled and deployed as a part of Databricks asset bundle with required schedule and triggers, job parameters, tags, and permissions. Let's take a look into what's being deployed as a part of this accelerator. We have built a visualization that captures the end-to-end process flow map of a system. So we can see this visualization not only captures the interconnectedness or the paths between the equipments, but also highlights whenever there is a component with critical health. Along with that, we also capture the near real-time health of the system. What's the probability of this? What probability of the equipment to fail in the system, and what's the downstream impact? All from one visualization. And also from the observability point of view, we also have built a dashboard that does not only generally categorize the equipment based on its time, but also based on its risk band, and also a view to observe the asset health over the time period to identify if an asset is burning at an unaccepted or an unforecasted rate. Also, along with this view, we also built a maintenance view. This is to unify to see a critical component and also the maintenance record of that component. So this view provides us a holistic view of the whole system. What's the component? What's its current health? What's its expected to be? And what is the probability of failure, along with when was it last maintained? How many days since it's last been maintained? And once it fails, what are the downstream critical important components that are about to fail? So this dashboard provides us with a unified view with respect to the asset health and their maintenance records over the time. Let's take a look back into our job that's being deployed. As we have seen in the Medallion architecture slide, all of this starts by ingesting the data onto Databricks. That happens in the bronze layer, and further this is being cleaned and kept ready for the graph model in the silver layer. And once the data is ready, we model it as a graph as we have seen previously. And all of these interconnections are modeled on Databricks, and this engine is also optimized to run only when there is a new data to reduce the cost of this operation. All of this data is further curated and aggregated for the respective business logics in the gold layer, which are further consumed by the dashboard and visualizations that we have seen. However, all of this data is schema, data, and business meaning enforced. How do we do this? We use data contract CLI along with our custom logic check each field in the table to match the requirements in the contract. So a data contract is a living contract between the data consumers and the producers. It is also a very widely used and accepted data quality tool. On the data contract HTML view, you can see we do have some basic details about the accelerator itself, the entity relationship diagram of the tables that are being produced, and the schema of those tables. Also, the enforcement rules, for example, require the asset ID in summary metrics is a required field, so there is no nulls expected or accepted in that particular table. All of these are being tested by the custom logic. If you see here, you could see that the field asset ID is being checked for three different conditions. If it is present, yes. If it is of type string, as on the data contract, yes. If it has no missing values, yes. And all of these which match with data contract are only then passed downstream components like visualization or the dashboard to consume this data. Also, all of this, since being governed under Unity Catalog, is exactly in sync with Unity Catalog for this respective table. We can see asset IDs of type string, and the description is unique identifier for the asset or equipment ID, exactly as is from the data contract. This helps us enforce not only the schema or data match, but also a business meaning match. Since we are governed under the Unity catalog, we also do get to use the features like details to check when was the job created, who created it, when was it last modified, the type of the table, and so on. We can also check for the permissions, who has access to what, and at Cavallo Technologies, permissions, ACLs, and governance is the core pillar. We deploy these through Terraform infrastructure to maintain the least privileges required for each and every one. We can also check out the history and the lineage to identify how has this table or columns in the table been modified over the time, and who's consuming this upstream and who's consuming this downstream. We can also look at the lineage graph to see the end-to-end transformation of a table or a field. For example, we can see how two tables transform to form a materialized view, and that's being consumed downstream. We can also trace back for each column, for example, asset ID, what's it upstream, and so on. We can also check out the insights and quality of for each table over the time to identify the quality degradation or anything if that's missing the enforcement. Now that we have seen the accelerator in operation from end to end, starting from the data ingestion to modeling, and then to how we curate the data in the goal, and what's the schema, enforcement, data quality enforcements, and ACLs that we apply, all of those tested in the data contract. Now let's take a quick look to see how all of this is being deployed. All of this is, as mentioned, bundled and deployed as Databricks asset bundle through GitHub. Whenever there is an approved commit to the main, then the workflow of this GitHub triggers, and it takes the whole bundle and deploys it into the targeted Databricks environment. And now that brings us to the end of the demonstration. Just to summarize, the Digital Twin Accelerator for predictive maintenance is fully automated, governed, and designed to accelerate the time to value by enabling rapid deployment of a modular solution across your complex operational environments. Thank you for watching till the end. Thanks for your time. Thank you.